Have you ever gazed up at the night sky, curiosity stirring within you? Have you ever wondered about your place in the vast cosmic ocean above? We dream of traveling to distant stars and to other galaxies far beyond our own. But have you ever imagined journeying to another time? For generations, the idea of time travel has lived in the pages of books and flickered across the silver screen. It has inspired dreams and sparked wild imaginations. But what if I told you that time travel is not just science fiction? What if the universe has hidden the rules for visiting the past and the future, woven into the very fabric of space-time itself? The journey from fiction to fact has already begun. The cosmos, after all, has a few surprises up its sleeve. The story of time travel isn't about fantastical machines, at least not yet. It's about understanding the fundamental nature of time itself. Is time a river, flowing in one direction? Or is it something far more complex, something that can be bent, stretched, or even looped? For over a century, science has asked these questions, and the answers are stranger than fiction. Once you learn the universe's rules, reality itself seems flexible. This is a mind-bending journey to the edge of what we know. Once we believed Earth was the center of everything. Then we discovered we are just one planet, orbiting a single star in a galaxy of billions. Our understanding of time is evolving. We experience time as a steady march from one moment to the next. Tick-tock. Let's not keep the mystery waiting any longer. To unlock the secrets of time travel, we must first journey back to the dawn of the 20th century. There, a young patent clerk named Albert Einstein was about to change our understanding of the universe forever. Einstein introduced two revolutionary ideas, special relativity and general relativity. These theories revealed that space and time are not separate and absolute, but woven together into a four-dimensional fabric, space-time. This fabric is flexible. It can be bent, stretched, and warped by matter and energy. This insight forms the foundation of modern physics and gives us our first real clue that time is not what it seems. One of the most astonishing consequences is time dilation. Time moves slower for objects traveling at incredible speeds. Imagine two twins. One remains on Earth, while the other boards a ship that travels near the speed of light. When the traveling twin returns, she is younger than her sibling who stayed behind. Time has passed more slowly for her. This is not science fiction. It's a fundamental property of the universe, proven by experiment. On the ship, everything feels normal. But compared to Earth, her clock, and every atom, ticks more slowly. This is the true power of Einstein's clockwork cosmos. You may be wondering, does any of this truly affect your daily life? It may sound like abstract theory, but the reality is far more practical. In fact, you rely on the evidence of Einstein's ideas every single day. The Global Positioning System, or GPS, is a direct result of our understanding of time and space. That small device in your car, or the phone in your hand, uses signals from satellites high above the Earth. These satellites are equipped with atomic clocks, and their signals help you find your way, whether across town or across continents. But without accounting for the strange effects of relativity, your GPS would quickly become useless, sending you miles off course in a single day. This is a silent testament to the fact that time does not pass at the same rate everywhere in the universe. Here's how it works. A network of satellites, about 31 in total, orbits the Earth, each carrying an incredibly precise atomic clock. These satellites travel at nearly 9,000 miles per hour, and according to Einstein's special theory of relativity, their clocks tick just a bit slower than those on the ground. The difference is tiny, about 7 microseconds each day, but it is enough to make all the difference in the world. Traveling to the future is not just a fantasy. Physics tells us it may be possible, though the technology is far beyond our reach. But what about the ultimate dream, journeying into the past? To even imagine that, we must get creative with the very fabric of the universe. Einstein's theories suggest a bold possibility, a structure called an Einstein-Rosen bridge. You might know it by its more popular name, a wormhole. Picture space-time as a vast sheet of paper. Normally, to get from one point to another, you'd travel across the surface. But what if you could fold the paper and poke a hole straight through? That's the essence of a wormhole, a tunnel connecting two distant points. In theory, a wormhole could be a shortcut not just through space, but through time itself. Imagine a tunnel with two mouths, joined by a single throat. Enter one mouth, and you could emerge from the other almost instantly, even if they're billions of light years apart. Now here's where it gets truly fascinating for time travelers. If you could take one mouth of the wormhole and accelerate it close to the speed of light, then bring it back, time would pass differently at each end, thanks to time dilation. One mouth would remain in the present, while the other would be anchored in the past. Step through, and you've traveled back in time, at least in theory. As we journey from the vastness of deep space to the tiniest building blocks of reality, the universe reveals even stranger rules. Welcome to the world of quantum mechanics, where the ordinary laws of nature no longer apply. Here, atoms and their subatomic particles behave in ways that defy common sense. In this realm, a particle can exist in several places at once and sometimes acts like a wave. Even the flow of time itself can become uncertain, blurring the line between past, present, and future. This opens up bizarre possibilities for manipulating time, far beyond our everyday experience. In classical physics, every effect has a clear cause. You flip a switch, and the light turns on. The cause always comes before the effect. But in some quantum experiments, the future can appear to influence the present, a phenomenon known as retrocausality. It's as if a particle knows what measurement will be made and adjusts its behavior accordingly. When we begin to seriously consider traveling to the past, we quickly encounter a universe of contradictions. These contradictions are called paradoxes, logical puzzles that challenge the very fabric of reality. Paradoxes have inspired countless science fiction tales, twisting our minds with their impossible scenarios. The most famous is the grandfather paradox. Imagine you, a time traveler, build a machine and journey back to the past. You arrive in a different era and prevent your grandparents from ever meeting. If they never meet, your parent is never born. And if your parent is never born, you cannot exist. But if you never existed, how could you have traveled back in time at all? This is the paradox, a dizzying loop that seems to make time travel to the past impossible. It's more than a philosophical puzzle, it's a real challenge for physics. If the universe allows travel to the past, it must also have a way to resolve these contradictions. How can reality avoid tearing itself apart with such logical knots? One possible answer is the Novikov self-consistency principle. This principle suggests that the laws of physics prevent any event that would create a paradox. You might travel to the past, but you would be unable to change anything that would alter your own future. The universe, it seems, protects its own timeline, no matter how clever the traveler. The theories of time travel are undeniably tantalizing, sparking our imagination and curiosity. Yet the practical challenges of constructing a time machine are, to put it mildly, monumental. The universe itself appears to have erected immense barriers, as if safeguarding the fabric of reality. It's almost as though the cosmos is protecting itself from the chaos that time travel could unleash. The very first and most daunting barrier to time travel is energy. According to Einstein's equations, bending space-time to create a wormhole would demand unimaginable power. Not just the output of a single power plant, or even all the power plants on Earth combined, but energy on a cosmic scale. We're talking about the power of a star, or even more. And then, there's another challenge, one we've touched on before, the need for exotic matter with negative energy, or even negative mass, to keep a wormhole open. Perhaps the most powerful argument against time travel came from Stephen Hawking. He proposed the chronology protection conjecture, the idea that the laws of physics conspire to prevent large-scale time travel. Hawking imagined that vacuum fluctuations could create a feedback loop of radiation, destroying any time machine before it could work. It's as if the universe has a built-in security system for the timeline. And just when we think we understand the rules of time, science throws us a new curveball. In recent years, scientists have discovered a completely new and bizarre state of matter, something that stretches our very definition of what's possible. It's called a time crystal. A regular crystal is a structure of atoms that repeats in space, like a diamond or a snowflake. Its pattern is periodic in the three spatial dimensions, but a time crystal's ground state has particles in continuous repetitive motion. Its pattern repeats not in space but in time. Think about that for a moment. Most systems, when left alone, settle into a static lowest energy state, but a time crystal is different. Even at its absolute lowest energy, it oscillates, ticking like a clock forever. The future of physics may lie in these strange, ticking crystals. Our journey has taken us from Einstein, gazing at the stars, to the mysteries of the universe above. Here, stargazers peer into the night, searching for answers. We've explored the bizarre rules of the quantum realm, where particles shimmer and dance in the darkness. We've seen how time slows for rockets racing through space, and for those who dare to travel at incredible speeds, and how massive objects, like black holes, bend time itself, a fact your GPS depends on every day. We've imagined cosmic tunnels, wormholes, where the laws of physics twist and turn, and we've wrestled with paradoxes that haunt our dreams of visiting the past, where time itself becomes an illusion. We've confronted immense energy barriers, explosions of power that challenge our imagination, and we've considered the possibility that the universe itself forbids such journeys, warping reality to protect its secrets. Yet we've glimpsed a new frontier, time crystals, matter that pulses with its own internal clockwork, shimmering in the cosmic dark. The science of time travel is a tapestry, woven from the proven, the possible, and the purely speculative, like rockets launching into the unknown. The journey to the future, at least, is a matter of engineering and courage. Building a ship to approach the speed of light is a challenge for the next generation of explorers and engineers. The laws of physics, as we know them, permit it, but it's a challenge of technology, not a violation of nature's rules. You could buy a one-way ticket to the 23rd century if you can build the vehicle to take you there. Travel to the past, however, remains a distant and uncertain dream, guarded by paradoxes, energy requirements, and perhaps the very laws of the cosmos itself. It remains on the very edge of scientific inquiry. The quest to understand time is in many ways the quest to understand the universe. It pushes our science, our technology, and our philosophy to their absolute limits. It forces us to ask the biggest questions. Where did we come from? Where are we going? Is the future written, or do we create it with every choice we make? These are not just questions for physicists in a lab. They are questions for all of us. They speak to our deepest desires, to correct our mistakes, to see our ancestors, old photographs capturing faces from the past, or to witness the grand future of humanity among the stars, where explorers build new worlds. The dream of time travel reflects our hopes and regrets, a silhouette against the cosmic unknown. And so, I leave you with a final question, a thought experiment to carry with you as you look up at the night sky. If the obstacles were overcome, and if a time machine sat before you right now, ready to take you anywhere, anytime, where would you go? What would you do? Would you visit the dinosaurs, see the building of the pyramids, or meet your great-great-grandparents? Would you leap into the distant future to see if we ever make it to other galaxies? Or would you be tempted to go back and change something in your own life? The choice is yours. The universe is waiting for your answer. If you enjoyed this journey, subscribe to our channel for more fascinating videos about the mysteries of the universe and beyond.